All right, in this example, we are going to look at dividing a fourth degree polynomial by a second degree polynomial. So this is definitely a little larger of a problem, slightly more complex than the one that we did in the introduction in the previous video. Now, something I want you to notice, here in our divisor, we have all of our exponents go in descending order without any gaps. We have a to the second power, to the first power, and to the zero power for our variables. However, in this example, it's a fourth degree polynomial, but we've got to the fourth degree, third degree. We don't have a term for our x squared. So we're missing a term for x to the second power. We go to x to the first power and x to the zero power. Now, when we go ahead and write our dividend here, we can't skip x to the second power. Okay, this is actually plus 0 to the second power. The way that we want to write this is in standard form with no gaps. So we're actually going to write, I'll show you right here. We're actually going to write, so in this place, we're going to write 0 to 0x to the second power. Now, the reason that we write that is when we go ahead and do our long division, we have to go ahead and account for each term as we subtract each number from the next. Now, you're going to see that what happens is, I'm going to go ahead and click through. There's a quick write-up here, and it says we have to use the same format as we do when dividing numbers. So just like if we're doing numbers, we always have to do 0 in the ones place or the tens place. We have to do 0 in each variable to the exponent. So what we have to do at each stage, we have to divide the term with the highest power in what is left next in the dividend. So that's how we get our quotient. So I'm going to go ahead and click through on this example, and I'll go ahead and fill in anything that needs to be explained. So what we do, just like I said, for our dividend, instead of just writing this out exactly like it looks, we're going to go ahead and fill in our placeholder for the exponent that's missing. It's really important that you do this, not just in dividends, but in divisors also. If you're missing any terms in your divisor, you also have to fill it in with a 0 times that exponent or that variable. So let's go through and do this. We're going to do it just like we did on the previous example. So what we're going to do first right here is we are dividing, we're going to take x squared and see how many times that can go into 2x to the fourth power. Now, since this has 3 terms in this right now, we are also going to be dividing into the first 3 terms right here. Okay, so you're going to have to remember it's going to be the first 3 terms, those are going to be dividing into these first 3 terms right here. So when we try to see what term we have to multiply x squared by to get 2x to the fourth, when we go ahead and multiply our terms back, we're going to be subtracting that from the first 3 terms here. So just remember that as we go back to our problem. So to go, we're going to start with this first term here. X squared has to be multiplied by 2x squared in order to make it match right here. So what you're going to see is we get 2x squared on top, and when we multiply 2x squared by our divisor here, we're going to get 2x squared by each of these 3 terms right here, and you're going to see that we get 2x to the fourth, and then 2x times 3x gives us plus 6x cubed. 2x squared times 2 gives us plus 4x squared. Now, in order to get the next term, we're going to have to subtract this entire polynomial from this one up here. So just like we learned in the previous section, we're going to be subtracting this polynomial here. So that's going to look like minus 3x cubed, 0 minus 4x squared gives us negative 4x squared. And right now, we don't have anything for the next term. So this is where you're actually bringing that down. So now, we are looking at what do we have to multiply x squared by to give us negative 3x cubed? Well, that is negative 3x. So negative 3x times x squared gives us negative 3x cubed. So again, we're going to go ahead, and what we're doing is we're taking negative 3x and we're multiplying that by all three of these terms right here. So negative 3x times x squared gives us negative 3x cubed. Negative 3x times 3x gives us negative 3x squared. Negative 3x times 2 gives us negative 6x. Now, what we have to remember is we are taking this entire term and subtracting that from this polynomial on top. So remember, again, any signs here are going to have to change when we distribute this negative to our entire polynomial. So what we get here, when we multiply, or when we subtract, this is going to be 0. Negative 4x squared minus 9x squared, that turns into a plus. We get 5x squared. 5x minus 6x, minus negative 6x gives us plus 11x. And we don't have anything, so we're going to go ahead here. We're going to bring down our negative 1. Now, we need to take x squared and divide it into 5x squared. So here, we need to multiply this by 5 to give us 5x squared. So we write plus 5 up here. Now we need to take 5 and we need to multiply it by 5x squared to get 5x squared. We need to multiply 5 by 3x, that gives us 15x. And we need to multiply 5 by 2, and that gives us 10. Now again, we need to make sure that we are subtracting our entire polynomial. As I've done each time, I always write parentheses around the polynomial that we're subtracting, so that we need to make sure when we subtract that, we remember that we are taking this minus and distributing it to each term here. Minus negative 3x is plus, minus 2x to the fourth, minus 6x cubed gives us minus, and so forth. So here we're going to see that when we take 5x squared minus 5x squared, that's going to cancel. 11x minus 15x is going to give us minus 4x. Negative 1 minus 10 is going to give us negative 11. Now you're going to see right here we don't have any more terms, and we're not ending with a nice even 0. So in this case, we're going to have a remainder. Now, in this case, our quotient is 2x squared minus 3x plus 5. That's going to be our quotient. And our remainder is going to be whatever we get here through doing this subtraction. So here we're going to have minus 4x, and here we're going to have negative 1 minus 10x. We're going to have minus 11. So in this case, this is going to be our quotient, and we're going to have a remainder of minus 4x minus 11. And remember, we always write our remainder as a quotient over our divisor. So we're going to write this as a quotient of minus 4x minus 11 over x squared plus 3x plus 2. So let me go ahead and get this up for you. You're going to see when we subtract this, we get 4x minus 11. And when we go ahead and complete this through, we're going to get our quotient here, 2x squared minus 3x plus 5, plus our remainder right here. So we get minus 4x minus 11 over x squared plus 3x plus 2. That's our quotient right here. So again, I know there's a lot of arithmetic that goes into this. That's why we learned how to add and subtract polynomials before trying this, because you'll see we have a lot of addition and subtraction with polynomials. But remember, this is all just vertical addition and subtraction. Again, key things here, make sure you write parentheses around these expressions right here so you always know how to distribute your negative signs when you subtract. Just make sure you keep track of all those signs so you don't mess anything up. And when you have a remainder, just remember you're always adding your remainder at the very end. Your quotient is what you get for your final expression plus whatever remainder you get. If you have any questions on this, make sure to replay it, go slowly through it, pause, try to get your arithmetic done, and then continue on to see if you got it right. Go back and rewatch this or rewatch the video before this to see if you need to get some more tips or kind of go over the examples again.